Hello, my name is Pascal Oferuf. In today's Zero2Hero video, we are going to talk about action-based extensibility in VMware Cloud Assembly. This is part 1. We are going to start simple. We are going to talk about what are action-based extensibility actions or ABX actions, what are the building blocks of those actions. We are going to build our first ABX action, and by doing so we are going to work with action inputs, context, and outputs. We are going to use some basic scripting operators to get us up and running, and we are going to talk about subscriptions or subscribing those actions to event topics. And at the end, we are going to take a look at a couple of examples how we can work with Cloud Assembly deployment payload in our actions. I hope you enjoyed, so let's start. What is serverless computing? It is an architectural approach for application development that emphasizes on the stateless function execution as a response of an event trigger. It requires a runtime platform or a set of servers to execute those stateless functions in. Function as a service or FaaS runtime platforms exist both for on-premise and in the cloud. Most used ones are AWS Lambda and Azure Functions or App Services. So in this context, what is action-based extensibility? Cloud Assembly utilizes FaaS to run actions or functions for workload lifecycle management, which is a new alternative coming from VMware compared to vRealize orchestrator workflows, which we had before and still have today. So let's jump into Cloud Assembly and create our first ABX action. We can find the actions under Extensibility, Actions, and when you create a new action, we need to specify a name and a project to create it in, and I've already done this to prepare with a very basic example. One of the first things we need to select when building a new action is to select the scripting language which we want to utilize in that action. We can choose between Node.js, Python, or Microsoft PowerShell. For the purpose of this video, I'm going to use mainly Python, but I may switch in and out to other languages to give some examples. We can either write the script here within the Extensibility tab, or we can import a package containing our functions that we want to execute. I'm going to talk about packages a bit later in this video. Let's take a look at the settings which are configurable for an ABX action. First of all, a new action will consist of a function. In this case, we have a function called handler that has two inputs or two parameters as an input, context and inputs. Currently, it has a variable outputs which is empty, and this is being returned out from this function. On the right side, we can see the function settings we can configure. Let's start with main function. In case we have more functions in our script, in our action, we can specify which is the entry function name that will be executed first when this action starts. For example, if I create a second function, I'm just going to copy the first one with name function2. If I want this function to start first, I will say function2. For now, I'm going to revert this back. Now, optionally, we can provide input parameters for additional input parameters for that function, which we can specify under default inputs with the name for the input and the value for the input. And we can add more if necessary. I'm going to speak about dependencies a bit later, but here is where you can add additional modules if these are required by your function. The FaaS provider menu allows you to select where this function can execute. We can leave this to auto select, which will automatically choose one of the available FaaS providers, or we can switch to Amazon Web Services, Microsoft Azure, or on-prem. Now, where exactly will this function run in each of these provider use cases? It will run to the corresponding cloud account or extensibility integration. And if we switch quickly to infrastructure, we can see that I have configured an AWS account, cloud account, an Azure cloud account. If I open AWS cloud account, I can see some regions which I found out for provisioning. These selected regions are all the regions in which Cloud Assembly will try to run an ABX action if I select Amazon Web Services as a FaaS provider. It will pick one of these on a random principle. Same goes for Azure. If I select Microsoft Azure as FaaS provider, it will pick any of the selected Azure regions from this cloud account. For on-prem, I need to install an integration, which is called Extensibility Actions on-prem. This will download an appliance in your on-prem data center, and once you install it, this can be selected so that actions can run on that appliance as well. For the purpose of this video, I'm going to stick mainly to Amazon Web Services. An additional field is going to be shown when we select Amazon Web Services or Microsoft Azure. Those additional fields or field will allow us to add the name of the IAM role within, in this case, Amazon Web Services, which can be used to elevate permissions or impersonate that particular role and run this action with maybe elevated permissions in Amazon Web Services to perform a given task. If we do not select any IAM role, whichever account was used to connect to Amazon Web Services under infrastructure cloud accounts, this is the account under which the ABX action will try to execute. This is the account that needs to have permissions to run one of the functions, in this case, in AWS. Now, in this example, I'm using a Python action running in Amazon Web Services, which means in every time I run this action, there will be a Python environment waiting for me in AWS Lambda, where this action will get triggered. The same is if I select Microsoft Azure, and the same applies if I select on-prem. As long as there is a Python environment running on those FaaS providers, they should be able to handle the execution of that action. Exception is made for on-prem, which is the only FaaS provider that supports PowerShell. If you're running a PowerShell action-based extensibility and you're using on-prem FaaS provider, this for each and every execution you do, a container, a Docker container will be spun, which will handle, contains the PowerShell environment, and it will handle the execution of this ABX action. For reference, this Docker container is being built from this particular image in the Docker Hub repository, which is being maintained by VMware. And you can see what the Docker image contains. It has PowerShell core, it has CLI 10, Power NSX, and a number of community modules and script examples are included. We can integrate our ABX actions with GitLab or a Git repository so that each time we click save here within the ABX action, this will trigger a commit of what we have changed in that action to a Git repository containing that action. And this is a two-way integration. If I do changes, on the other hand, on the Git repository side, those will show up here as well. And you can see these if you go to versions. In this example, I have created one version of this particular workflow. And in this case, I'm not using action-based extensibility. I'm not using Git integration, but if I am here next to the version, you're gonna see a small Git icon stating that this version is a particular Git commit operation. And you're gonna see the Git commit ID and so on. How do you configure Git integration for the ABX actions? You do this via another integration called Git. I will open one which is already configured. As you can see, currently I have two Cloud Assembly projects which are pulling or pushing blueprints to a particular Git instance. If I want to create a Git connection to my extensibility ABX actions, I can do so by creating action-based scripts as a type and specifying the repo where I want those actions to be synchronized in. Now this is a neat feature, but it comes with a couple of caveats. Once you configure that integrations for a particular project, all actions in that project will be synchronized on that Git repo. So make sure when synchronizing to public Git repos that you don't have sensitive information within your scripts that may get published out in the open. If you want to use different Git repos, you have to use different project and assign each repo to a different Cloud Assembly project. Now let's test our function. This is a very simple function that isn't doing anything. And as we can see, it just takes the inputs, action inputs, which we have specified. It will run this particular function in Amazon Web Services, which doesn't do anything at this point, and it is not returning anything as well. Now let's talk about the parameters the function accepts on the function inputs and the function outputs. You are going to want to use this all of the time. The context parameter or the context input handles the authentication from Cloud Assembly to through the cloud account, which is configured, to the function as a service provider, in this case AWS. If you don't have this, include it as a parameter to your main function, execution may fail, and it will fail. The second parameter or the second input is called inputs. This has two functions. When used and when this action is subscribed to a particular event topic, it will provide you the payload or the metadata of the blueprint deployment coming from Cloud Assembly. At the same time, it will provide you all the inputs configured under default inputs within your action. I call them action inputs. The return variable, or in this case outputs, which gets returned from this function, will be returned back to Cloud Assembly, to the event broker service, if we use blocking subscription, something which we are gonna see a bit later on. What is the inputs parameter? In this case, we are working in Python, so this is a dictionary object. In other, which is in Python, dictionary objects are the representation of hash table objects. If this was a Node.js or a PowerShell action, that would be a hash table objects, meaning any operations you can do with hash table objects or with dictionary object in this case, you can do them here as well. So if you need to figure out how to parse all the components or all the key value pairs of an inputs dictionary, in this case dictionary object, you can Google this and you get tons of example how to do this in Python. For me, a dictionary object or a hash table is a crossbreed between a typical JSON string and an array of strings. Let's give a quick example. Here I've defined an empty dictionary object called all inputs, and then I'm assigning values to that particular dictionary object. As you can see, this is a typical JSON string with three key value pairs: key name, value Zara, key age, value 7, key class, value first. Now, if I copy this to, let's say, an online JSON viewer, like the one you can find on jsonviewer.stack.hu, we can see that this resolves to a standard JSON string with three keys and three corresponding values. Now, let's assign this dictionary object which we just created with those values to our outputs. And before that, we are gonna also print that value to the console. Let's click save and trigger another test. We can see again all the inputs coming from the action inputs. And this time we also see in the outputs all the dictionary key value pairs which we have specified in all inputs, as well as in our console where we have printed the entire dictionary object. Now, let's connect this ABX action to a particular subscription and see what we are gonna get from a simple machine provisioning. I'm just gonna simplify this action and say whatever inputs I get, assign them to the outputs and return those values. And in this way, I'm going to basically output the deployment payload, which is coming through the inputs parameter, and see it in my action. I'm going to click save and close. I've already created a new subscription, but feel free to do so while you test this, and you can test this as I move along. This connects to a compute allocation, event topic, and this is one of the first event topics which get triggered once a new deployment has been requested. And we can see here the schema that this particular event topic has and all the different schema elements that it is going to return for us in the event payload. Let's go back to that subscription. We can apply filters or condition filtering for a particular subscription. We can, for example, say run the subscription or run the corresponding action which is selected underneath if a particular username triggered a particular deployment, if a deployment was triggered for a particular blueprint with a given ID, and many more. You can filter based on the source types, event types, usernames. You can filter, for example, and say that you want to trigger this particular action only when a particular custom property has been configured or when the requested deployment has been provisioned on, let's say, Microsoft Azure, only then trigger a particular action or a workflow. I'm not going to apply any filter condition. In action workflow, we have to select the action we want to trigger once this event happens, takes place, and I have selected my ABX action. If I'll be modifying the payload from this particular event, from this particular deployment, with a value, for example, I want to change the host name of the VM or the IP of the VM or something else which I want to return back to the event broker service, back to the provisioning service, so that the new value gets taken into account for that provisioning. I have to mark the subscription as blocking. If I do not mark it as blocking, once this event gets fired, once this subscription gets triggered, the deployment, the provisioning engine will not hold and wait for this action to complete and return the result, but it will continue with the provisioning process. And if we click and enable blocking, the provisioning service will wait for this action to complete and return the output back to the provisioning service before it continues with execution. And we can also limit the scope of the subscription to a particular project or activate this for all projects. I'm going to leave all projects, and actually I'm going to click cancel because I've already configured this before. For the purpose of this exercise, I have a very simple blueprint, which is called my first ABX, and that blueprint deploys a single machine resource and it connects it to a network. So let's deploy this and see what happens. I'm going to give it a name. I'm going to click next. I'm going to select leave the defaults and say provision to AWS. I don't really care in this example. and I'm going to click deploy. In a few seconds, if we go back to extensibility actions, let me delete those old actions. A new action run for our action will be triggered, and you can see this is currently deploying, and shortly after this will finish. As you can see, it actually already completed. Now, compared to before, where we only have our action input as inputs, and we didn't have actually any outputs, or we have only our dictionary example as an output, now I can see the entire payload belonging to that particular event. And as I said, this is a full form JSON. And if I copy this and paste it back into our JSON editor, I can see this is the payload coming from that deployment. And it has all the schema elements which we saw in the event topic, like tags, which for example are coming from the tags configured for this particular in this particular machine resource under tags. It has the tags. It also contains additional information like all the custom properties, the image which I have selected, the flavor, the SSH key which was used for that particular machine resource, and so on and so on. You can also see that together with the payload from the deployment, this also shows me the ABX action input which I have defined, which was ABX input name and ABX input value. This is the action input which is defined again in my action on the right side under default inputs. Now, what does this mean? As I already said before, inputs provides me with the entire payload for that event, the inputs parameter, but together with this, it provides me all the inputs which are configured in that action. And this is my personal preference to avoid an overlapping of input names coming from the payload and those defined in the default inputs fields. For all inputs I define in my action, I add the suffix in. In this way, I know when I read the payload afterwards, I know which actions are coming from the ABX itself and which actions are coming from the particular subscription and the particular event topic. Now let's see how we can modify that particular payload and change maybe some of the properties. Let's, for example, take the SSH key, which is being configured under remote access property for that particular machine resource. Let's say I want to change this in my ABX action and assign a new value and then return this output back to the event broker service, back to the provisioning service, so that the new payload takes an effect. Okay, let's go back to extensibility and let's change our ABX action. So what have I added or what have I changed from the previous ABX action? I've created a new string variable, new key, holding my new SSH key. Again, I've defined an empty outputs dictionary object, which is going to contain my custom properties that I want to change. And on the next line, you can see that I'm taking this dictionary object, I'm creating a new key inside called custom properties, and I'm assigning to that key all the custom properties with the same key name coming from the inputs or coming from the payload, which means I'm basically saying from the payload that is coming from the deployment, take this, take all the values under custom properties and assign them to my variable or my dictionary object called outputs and assign them all in the key custom properties. So I'm taking the custom properties from the inputs from the payload and I'm assigning them to my dictionary objects so that I can subsequently change them. And in the next line, I'm doing exactly this. I'm accessing my dictionary object, I'm accessing my custom properties key which is within that object, and then I'm accessing again in the same fashion the nested SSH key element within that JSON. Or this is me looping through this JSON, going to custom properties, going and selecting SSH key, which is a nested key under properties in this JSON. And I'm saying assign a new value or assign my new SSH key or new key to that as a value to that property, that key property. And then I'm sending these two outputs so that this gets returned back to the entire payload and back to the event broker service and the provisioning service. I'm going to click save and I'm going to run another deployment of this blueprint. Again, I'm not going to change anything from my inputs. If I take another look at the action runs, in a couple of seconds, I should see my action running again. And if I open this, again, it's going to take just a couple of seconds. I can see this already completed. And if I scroll down and take a look at the inputs and take a look at the SSH key coming from the deployment payload, I can see the SSH key defined in my blueprint. And if I check the outputs, which are returned by my function, I can see that now I have changed my SSH key to my new SSH key. So this was an example of how we could take the payload of a deployment through inputs, parameter in an action, modify a given value, and return this particular value back to the event broker service, back to the provisioning service. Okay, let's get back to our action. This was a simplified example of how to manipulate the payload. Let's talk now about more about dependencies and what this means and how we can use them within our actions. Now this is a more extended example of the same ABX action, but in this case I'm doing a couple of things differently. I'm using an additional library called requests to which is an HTTPS library that can be used to execute HTTP requests if needed. And in this case, I'm using that library to pull that particular SSH key from an URL. In this case, I'm pulling this from a GitHub repository. Now, this is a requests Python module. And if I go in internet, I can find this module, which is currently at version 2.23.0. Now, stepping back a bit, if I'm just simply running, let's say, a Linux OS, and I install Python there, and I want to use the requests module, I'll have to run pip install requests to deploy that module into that Linux box. And then next, within my script in that Linux box, in order to use this requests module, at the beginning of my script, I will add a line like this: import and the module name, import requests. This is the same you have to do here within ABX Actions. If the module, if the library you are trying to use is not out of the box installed within the scripting environment where you're running this particular function within that function as a service provider. In this case, under dependencies, I will need to specify the name of my module, which again, it's requests. I can take it from here. And if I want to install a particular version of that particular module, I can do so by adding equal and the version name. And you can get some examples from the info tooltip. So each time my function starts, it's gonna install that module. It is going to import it in my function, and then I can use it throughout the lifetime of that function. Now, if I'm running this on-prem, or maybe my in a V-Ray instance where I don't have internet access and I cannot pull the dependency from internet, because this is what's happening if I enter a dependency here, I can do something else. Instead of writing the script here, I can create or import a package. I'm gonna close this and create a new function, a new ABX action to show you this. This is a new action I just created. It's still not saved. And if I switch to import package, I'll be presented with this window where I can click import and import a zip file containing the functions I want to import. The negative side of doing this is that I cannot edit that file once it's imported. If I need to make a change in my action, I need to make that change offline, package this action again as a zip file, and import it again here in by using the import button in this particular action. The positive side is that I can include in that package custom libraries, which may not at all be available in internet for download. On the right side, I have to specify again the file name of my main, in this case, Python script. Let's say my Python script within this action is called my action dot py, right? So I need to specify the name of that file, my action dot, and then the name of the function within that script that will be executed first. And if I kept the same naming convention, if I code that function handler, I will be specifying here my action dot and the name of the function handler. And everything else from the settings, from the configuration options for that action is the same as before. we are back into our main first ABX action, and we are gonna revert some of the changes back to where we are just printing the payload or the inputs of that action and providing this as a return to that action. If you go back to our blueprint, the custom properties example we saw earlier, or all the custom properties you see returned in the payload under custom properties, these are all the values that are contained within your blueprint under the properties property. I'm going to show now how you can take an user input, which a user specifies during provisioning of this blueprint, and how you can pass this user input again as a custom property into the payload of that deployment. Because we have no way of reading those inputs currently in an event broker topic. But this example can be used to attach any piece of information to the custom properties within the payload of any particular deployment. I'm going to create a new property which doesn't exist in the schema. I'm going to call it user input. For all the custom properties I create, I put suffix prop at the end so that I can easily identify them when I read the payload or when I'm looking at the blueprint. I'm going to say next, the value of this custom property should be taken from the inputs and in particular from the user input input. I'm going to do another run of this deployment. And this is the value which I as a user have specified or I am specifying during blueprint provisioning. Again, let's go to extensibility. Let's go to actions. And in a couple of seconds, we're going to see our action executing again. And if I open this and scroll down, I can see again the same payload as before, but in this case, under custom properties, I see our YAML custom property and the corresponding value. And just for a compare, before that value was not present within the JSON payload. But now if I copy this and load it within my JSON viewer, I can see I didn't copy the correct one. I can see that now under custom properties, I see this additional YAML custom property, which I have specified within my blueprint. This is a neat trick to pass any type of information in that blueprint to the payload or to the custom properties part of the payload of a given deployment. It can be used for anything you need it to be used for. In this particular example today, we have used Python to build our action. Just for a reference, I've built a fairly simple but still more complex than this action to integrate with Slack and post deployment information to a given Swag channel, and I've built this action, exactly the same action, in all the different languages, programming languages. I've built it in Python, Node.js, and PowerShell, and I have placed this in the VMware Code community page, which is code.vmware.com. You can find those samples when you go to samples, navigate to multi-cloud operations, vRealize Automation Cloud, and search for my contributor username, which is spas_Kaloferov. And if you open this, feel free to download those actions and see how exactly the same operation can be done, or set of operations within an action can be done in each and every of those scripting languages, just as a reference. How you can define variables, how you can parse content, how you can modify that content, those properties, and output them, or in this case, again, use the requests module to do post calls to Swag. The actions are Swag post deployment into Swag using Python, again using Python, and using Node.js and PowerShell. Thank you for watching and stay tuned for part 2.